Hi, everybody. How's it going? Can you hear me okay? Getting thumbs up. Hi. Ida, how are you doing?
I'm good. Yeah.
Great. Great. Well, it's nice to be with you all today. Honestly, mostly I'd love to just hear your questions, but I can talk a little bit about what we're doing first, and then we can get into any questions that you might have. So I run a company called Virgin Galactic, and it's trying to open up space for the rest of us, basically. And it's a way where we have a system. I don't know if you've seen a picture. I can pull up a picture actually if you'd like. But basically, it's let's see if I can pull up a picture. We have a really amazing team of people in New Mexico and in California that are building this terrific reusable space system. And let's see if I can show you a couple pictures of it. So, yeah, so we were started a while ago, but really back in 2005. And there was a program called Spaceship One, which went to space a couple times. And it was this amazing little vehicle. And basically, there was a guy named Richard Branson who said, hey, if this works, then we could use it to create a commercial service to take people into space. And that's basically what we've been doing since then. In 2018, we took our first flight to space. And then we did it again in 2019, this time with somebody in the back of the ship, so sort of like the first pilot, basically. And yeah, and here's a picture I can show you. So let me just sort of share this here. One second here. So I think you probably are familiar with it here, but can you see my screen here? Is that okay? Yeah. So you see the spaceship is the one in the middle here, and then the carrier aircraft is around it. And so what happens is we bring the spaceship up to about 45 to 50,000 feet in the air, and then we release the craft, and it shoots on up into space on a parabolic trajectory. It tops out over 50 miles high. So just to sort of give you a comparison, that's about 10 times as high as a normal airliner goes, roughly. So it's pretty high, but basically you're just going into space, and then you float around for a few minutes, and then you come back in. And we're doing this from a terrific place in New Mexico called Spaceport America, which is this really beautiful facility that the state of New Mexico basically built for us. And I can show you a picture of that as well. So here's a picture of that. Yeah, so you can see it's this cool round shape. We have this entire building here in the middle. And we can fit 2 carrier aircrafts in the middle of this building, as well as 5 spaceships. And then this is the tarmac surrounding it. We train the astronauts in the front, the glass part of this building here, and then the staff has offices in the back. And so that's the basic layout of the vehicle and the craft and everything. And so that's what we're doing. So in terms of people, we have about 600 people signed up who've paid for tickets, and another 400 people who've said that they would like to, go on up into space with us. And so we got a lot of people who want to go. So about 1,000 people have already signed up to go. And yeah, basically we're getting close to doing that. We're sort of in the final stages of our efforts. And I'll just show you a couple last pictures, I think, if I could, and then we can open it up for some questions. I saw we got a couple of questions. there. So let me just show you a couple last questions here. So a couple last slides here. So this is a picture, this is a picture of what it looks like from space here. And you can see it's very beautiful. This is a picture of what it looks like when we're floating around in space. So you can see one of the things that I like about this picture is if you look at the visor of the pilot on this side, you can actually see the Earth reflected in his goggles. But this person who's floating around in the back is named Beth Moses. She was the first, really the first commercial passenger to go to space. And she's also our chief astronaut instructor. She worked at NASA for many years and is now working for us. So we also went, we did a public offering. We don't really need to talk about that. That was last year. So we're a publicly traded company on the New York Stock Exchange. And yeah, so this is a picture of the spaceship just by itself. And those are all the people that were required to build that vehicle. And so it takes a lot of people to build spaceships, basically. And so if any of you are interested in working in aerospace, I'd love to answer any questions you might have about, you know, what kind of education you might need as you go forward, or other things like that. So I think that's basically it. You know, it's a super exciting time in the space industry. You know, there's so many different companies that are you know, working on different aspects. There's some companies that are building things that will go to the moon. There's other companies that are going to Mars. And then there are a lot of companies that are going to other places. And in addition, you know, there are all the national space agencies. NASA is one of them, but there are others out there who are also doing really exciting things in terms of exploring different planets or exploring, you know, through astronomy outside of our solar system. So I think, you know, the opportunities that you'll have as you go through your career, if you're interested in space, are tremendous, right? I mean, so you know, up until this point, only about 500 to 600 people have ever been to space. I think we'll start doubling, tripling, quadrupling that quite quickly over the next few years. And so many more people will have the opportunity to go to space. I think that we'll have the opportunity to use space transportation to go between points on the Earth's surface. So we'll be able to go much faster. We'll be able to use Earth monitoring satellites to help understand the Earth as a system, almost as a spaceship itself. And I think that that's one of the most important things that your generation will be able to work on, is understanding how the Earth works as a system, and then understanding how humanity is having an impact on that system, and then designing ways that we can, you know, basically live on the planet in a way that works for all the other life on the planet and our spaceship, the so-called spaceship Earth concept. And I think that that's really one of the most important things that your generation will be able to do, is to really understand the incredibly complex interactions within the Earth spaceship system, and to design ways to have Earth humanity live sustainably with that. One of the other things that we're really excited about is the idea of something called the overview effect, which is this term that refers to the change that astronauts go through when they go up into space and they look down at the planet. They experience this sort of philosophical shift in their thinking from a neighborhood or even country-specific view of the world, or of their sort of home, to a planetary view of their home. And I think that shift, which I hope many of you probably already have, given, you know, the great backgrounds you come from, I think that shift to a planetary worldview is one of the most important shifts that we can have to address some of the biggest challenges that we have coming down the road. So those are all Earth-focused things. And then, you know, going outwards, I think that your generation will have the opportunity to be, you know, explore the moon, explore Mars on foot. You know, like you can actually go there, or at least, you know, some astronauts will be able to go there from different countries, I hope. And then through long-range astronomy, we should be able to start doing spectroscopy of other planets around other stars, and we'll start to get a sense of whether there are signs of life around other on other planets. We won't necessarily be able to tell like what that life is, but we'll be able to see the presence of life on other planets, which will be really exciting, I think. And so, there's this tremendous range of opportunities for you all as you look forward in your lives and your careers of discovery and opportunity, both learning about the universe, learning about whether there's life out there, whether it's in our solar system beyond Earth, or whether it's beyond the solar system and other star systems, to technology, like building new spaceships, building new transportation systems, building systems that have low to zero carbon footprint, understanding the Earth as a system, and designing, all the technologies that will be needed to work and live in a sustainable way. And that's a hugely exciting future. And all those technologies, are nascent now, but you'll be able to develop them, draw them out. And so, for those of you who are interested in engineering or science, or really anything, business, marketing, other different things, you'll have a chance to connect into these world-changing technologies that will really play a key role in the future of humanity, whether it's sort of how we live on Earth or how we explore beyond Earth. So you're in a great place. You've got, I don't know, probably you have 60 to 70 to 80 years in front of you, hopefully. Maybe like the lifespan of humans will go to maybe average 90 or 100 over the course of your lifespan. So, you have a lot of time. And so you'll be able to try a bunch of different careers. You'll be able to try a bunch of different jobs. You'll be able to connect into all these amazing dynamic things that are available to those who, study in the right way and connect in with the right educational path. So, I'm really excited for you as future leaders and as future technologists, future engineers, future business people, to see, what you do. And because there's a lot of great possibility going forward. And Virgin Galactic is just sort of one example of that. So anyway, that sounds like a good way to start. Why don't I stop there, Jada, and maybe you can lead us through these questions, or I can just answer them, whatever you want.
Yeah, sure. So I think some people had some questions in chat if you want to answer those, and then afterwards people could raise their hands.
Okay. So should I just go through these questions one by one? Is that good? Or how would you like to do it?
Whatever you prefer.
Whatever I prefer.
Yeah.
Okay. Okay. Whoa, that's a good reaction. That's a good one. Okay. What is the benefit of launching from the air other than starting with speed and having to push through a thinner atmosphere? Is there any benefit of launching from the air? So the number one benefit is that with a rocket that launches vertically from the ground, you have potential safety risks in those immediate seconds following launch. So like at that moment, you're going very slowly and you're quite close to the ground. So if anything goes wrong, you're in a challenging situation. The nice thing about using essentially a jet engine to take you up to 50,000 feet is that is like literally the safest form of transportation on the planet. Jet aviation is the most reliable form of transportation on the planet. You use the most reliable form of transportation to get you up to 50,000 feet. And then you can release, and then ideally everything goes great. But if everything doesn't go great, then you have 50,000 feet of margin to sort of deal with it on the way down. And that's a real benefit. It also means that the aircraft itself doesn't have to have the fuel to go from 0 to 50,000 feet. So the spacecraft can be smaller, more efficient, and then its rocket engine can be smaller. So we have less emissions from the perspective of a rocket ship that would be launching from the ground. So those are all the potential benefits of launching. We actually don't get a lot of help from launching at 50,000 feet in terms of energy, because we're not going that fast. If we were going a bit faster, like Mach 0.8, we would get more benefit. But as it is, most of the benefit is around safety. Okay, so are you bringing the passengers to space? That's the idea. So we brought our first test passenger to space, but we haven't started commercial service yet. So we're hoping to do that over the coming months or year or so. What does the road to profitability look like? Ignore if you can't talk about it. I mean, it's not that complicated. Basically, we're going to be charging a few $100,000 per seat, which is a lot of money. But I like to say that the only other way to go to space right now is with the Russians. That's going to change in a little bit, but right now it's with the Russians, and the Russians charge NASA about $80 million a ticket. So if we charge, $200,000 or something like that, that's a factor of 400 cheaper. And that's really exciting when you're talking about exponential reduction in cost. That's really exciting. So basically we'll have a, pretty good price, and we'll be making $1 million, $2 million bucks, $1 million bucks. I don't know, some low number of millions per flight. And that'll be a profitable business once we get up and running. What education do you need to become an astronaut? The most common way to do it is to get an engineering or a science degree. period. That's the most common way to do it. It's very rare that anybody goes in with a humanities degree. Nobody actually does that yet. But I mean, obviously you will be able to do that in your lives. It's just it hasn't really happened yet. The only people who have had humanities degrees who've gone into space have been those who have, I think, bought their own ticket somehow. Now you'll have the opportunity to buy your own ticket, and we're really excited about bringing artists and writers and poets and photographers into space because we really haven't done that yet. And I think that'll be in reporters and other folks who are not technical. But the most classical way to become a government astronaut is to get a technical degree in engineering or in some kind of hard science. And then and then you do something interesting, and then you apply for NASA. And usually it takes a few times to apply to NASA before you get accepted into the astronaut corps. So if you get rejected the first time, don't worry about it. That's actually very common that you don't usually get in your first or even your second application. They really like to see a few applications. Many other people will, if you want to go and be a flight side, they'll also go into either Air Force or Navy or another one of the military branches and get some flight experience on a fast jet or some other platform. And you're basically operating a very high performance vehicle, whatever you're flying to space. And so they like to see that. That's only if you want to do sort of the piloted track. Okay, is there any ways for high school students to work or intern at Virgin Galactic? So we typically have not had high school student internships. We have had collegiate internships and graduate student internships. It's something that we're thinking about. So you're always welcome to apply, and who knows, maybe if you're spectacular, we would consider taking you. So anyway, that's the short answer. We're not saying no, but it's just we haven't done it. We haven't done it to date. But once you are in college, we'll definitely we bring in about 30 to 40 to 45 students every summer. Even this summer with COVID, we're going to start them out remotely, and then they'll work hopefully in person in July. What are my thoughts on the Artemis program? So the Artemis program is the NASA's program to return people to the moon. I think it's terrific. Seems to be going pretty well. I think it's still early days in that, but I mean, the moon is very close and it's a great target for human exploration. And I hope that they have success. Are there any planned missions with NASA, SpaceX, and any plans to assist with NASA missions? So we fly NASA experiments to space on board our vehicle, Spaceship Two, today. And we've done that a few times, and we're really great, happy to do that for NASA. NASA's also announced that they're going to have a new category of mission where you can propose to fly not just an experiment, but you also fly along with that experiment. And so if as you get to college, you can potentially apply for that. And that might even be a way where you could go to space, even in college or in graduate school, which would be pretty amazing because no generation has had the opportunity to do that to date. But you will potentially have the opportunity to do that. So you would be operating your experiment in space. And that's one of the things that we've actually been proposing a lot is to say, like, what if NASA had a program where, like, every year they picked 2 students from every state to fly an experiment and to fly with their experiment into space. Wouldn't that be amazing? I would get a lot of people excited about science and aerospace and just create this amazing cadre of people who are interested in it. Okay, so do you think it's probable that there are other intelligent life forms out there? So I think it's super likely that there is life somewhere in the universe. I mean, the universe is unimaginably big. It's really hard for human beings to conceive of how many planets there are in just our galaxy. I mean, there's order of magnitude 100 billion stars, I think, order of magnitude. I think that's right. Correct me if I'm off by 1,000. But and I think it's becoming pretty clear that, on average, every star system has at least a planet. I mean, on average, and probably it's more. So, you could be talking about hundreds of billions of planets. And even if it's incredibly unlikely that there's life on other planets, when you're talking about a denominator of hundreds of billions for one galaxy, and there, I don't know how many, trillions, I don't know how many galaxies there are in the universe, you're talking about huge numbers. And so I think it's incredibly likely that if life has popped up on Earth, it's probably likely that it's somewhere else in the universe. Now, what's interesting is how common is consciousness or intelligent life. We don't really have a good sense of that. We have no data. We have a sample size of 1. But, I tend to think that throughout human history, humans have sort of suspected that they're the center of the universe or the center of whatever, center of everything. and usually they're not. There's this sort of old astronomers' view that the sun revolved around the Earth, and then there was the view that that we were the center of the galaxy or whatever. And I think that we will probably find that we're not that special. I mean, I think we're special. You probably think of yourself as special, and in a way, you are. Human consciousness is intrinsically special, but the idea that we're unique as intelligence is probably unlikely, I would say, but we don't really know. How does Virgin Galactic's goal differ from SpaceX, NASA, and Boeing? I mean, Boeing's huge, right? Boeing is like this, huge company. It does almost everything. NASA is, is huge too. It does everything. SpaceX is big. We're relatively small, and our goal is just to operate Spaceship Two, bring it up to space, and expand the number of people who can go into space dramatically. And then someday we hope to convert that technology so that we can go from one point on the Earth's surface to another point on the Earth's surface very quickly. And I think that would be very exciting if we could, if you could go to Europe or go to Asia, in an hour or two, and do that in a sustainable way. So I can come back to that during maybe Q&A. Okay, how does Virgin Galactic regulate carbon emissions and do missions sustainably? Yeah, so as I was saying, doing air launch reduces the amount of carbon footprint that we have significantly, but it's not zero. And so we're looking at other ways. I think what we're going to do is we're going to have buy offsets at least for our emissions. So at least on a sort of a net basis, our emissions will be zero. But the more we can reduce the actual emissions, the better. And we're looking at a lot of ways we can do that. Our rocket motor is very small compared to other systems, very small, and so it emits very little. Just to give you an example, like if we operated a few hundred flights in a year, it would have the same carbon emissions of like one big airliner flight across the Atlantic. So it doesn't have a huge amount of emissions, but it's non-zero. Are the rockets reusable? So the vehicle itself is reusable, but we have like a cartridge in the back of the rocket motor that we change out every time. So we have to change that out every time. What is my personal life mission? Personal life mission is basically to convey to people that we're living on a spaceship, and it's up to you all to figure out how to operate that spaceship responsibly. That's the main thing. I think if we do that as a human species, we're going to be okay. We can talk more about that in the Q&A. Make transportation from one place on another. Do you have plans to have Virgin enter this industry in the next 5 or 10 years? Yeah, we're actually designing a vehicle now that can go quickly between different points on the Earth's surface, and we can talk about that if people are interested in it. Do you expect to lower prices at some point so that it's available for more of the population? Yeah, obviously most people can't afford $250K. Yeah, we'd love to bring that cost down. I like to say that my goal is to bring it down to the cost of an SUV. I think it's the SUV barrier that will enable a lot of people to do it, right? Because then you can finance it, and that would mean that almost anybody, at least in the developed world, could afford it. So that would be fantastic. Okay, and what was the most difficult part of starting up this project company, and how did you find funding for the startup? Well, we were very lucky in the sense that we had Richard Branson essentially backing the company. So in terms of fundraising, we had an easier road than many people did. But it was still challenging, but like we at least had Richard Branson in our corner. The most difficult part were probably some of the technical challenges. Just getting a system that's highly reusable is very challenging when it comes to space transportation. And so, the engine and certain aspects of the control system, we've solved, we think, these challenges, but there's still, there's always work to do in terms of testing. I think the Drake equation actually tells us how many possibly habitable planets there are out there. The Drake equation definitely does do that. The challenge is that we don't know exactly what the parameters, the value of those parameters are, like, what percentage of life turns into consciousness or whatever. And we can talk about that. Well, we don't have all the values for the Drake equation. Indeed. True, but we know what the number would be quite large. True. You guys are working it all out in real time. I like it. To the precision, we would need to make a reasonable precision. Yeah, that's right. Yeah, what do you think about mining asteroids and other forms of commercialization in space? Long term, I think it's super exciting. Right now, it's just too expensive. So right now, it costs, you probably know, like about $10,000 to put a kilogram into space, order of magnitude into orbit. And so that means like any machine that you would use to bring it down, you have to have something that's like probably way more expensive than that. You know, and so that means that anything you do, so like what is worth $10,000 a kilogram, or what is worth $50,000 a kilogram? There are not too many things that are worth $50,000 a kilogram today. Now, if you substantially reduce the price, then it'd be terrific. Then you can mine all the metal that you want, do all this other stuff. But that would be super, super amazing. Okay, so space resources, any plans to trips to the ISS? I think that's pretty interesting. And what effect do you think this would have on amateur astronomy, especially if more people have access to space? I don't think it'll have a big impact on, I mean, hopefully it'll make people more enthusiastic about amateur astronomy. Our little vehicle operates during the day, so it's not going to have a big impact on, sorry, my kids want to come in, on amateur astronomy, unlike maybe the Starlink stuff, which we can talk about. But anyway, let's see. I'm just free associating here, and I'm looking forward to having like an actual conversation rather than just gold is about 56,000 per kilogram. There you go. So if we could find pure gold, that would make sense. Actually, some people are taking like wine up, and they make that seems to make sense. Okay, great. So I think I've sort of answered all of the questions. Why don't we have like a real engagement? I'll put myself on mute and listen to your questions, and then we can go from there. I don't know how to do the hand thing, so you'll have to help me. You know.
Yeah, of course. All right, Remy.
Can everybody hear me? Okay, great. So I was thinking about the forces of reentry and how that might affect your shuttle. Specifically, every so often do you have to replace it due to the forces of reentry? Also, how do you deal with heat damage caused to your shuttle because of the forces of reentry and the extreme heat of coming back into the atmosphere?
So because we're only going up to 50 miles, Remy, we don't have super high heating. So it's like a few hundred degrees. Now that it's a few hundred degrees, you know, so we need to make sure that we manage that properly, but we don't have to have like a ton of thermal protection for our system. And we do have a bit on the leading edges where it gets hottest. And we use different forms of thermal protection for that. We have one that's sort of almost like a felt, it's a high temperature felt. It's not really felt, but it's like, you can think of it as like felt. And actually they use that material on the coolest parts of the space shuttle. So on the top of the space shuttle, they use this material, and we're using it on the hottest parts of our vehicle. So it just gives you a sense of the difference. You know, we're going about Mach 3, you know, to go orbital velocity, you need to go about Mach 25. And the energy in your system, I think, is proportional to the square of your velocity. So you can sort of imagine, okay, 3 squared versus 25 squared, you know, to go orbital velocity, you have this like much higher energy. And that plays into reentry, because basically you need to take all that energy out of the system somehow when you're reentering. And you do that basically through friction and heating up air molecules and heating up your vehicle as you bash through the air. So when we bash through, we're going through with much less total energy than a vehicle that's going the velocity of orbital velocity. Does that answer your question? Terrific.
Gurmahar?
Can you guys all hear me? Just mic test, everything? Awesome. So I remember you said that your carbon footprint was non-zero. That just led me to think, what fuel are you using in the rockets? Is it just, you know, like liquid hydrogen, liquid oxygen, or is it something else that combusts and releases CO2?
Yeah, it's essentially, it's called HTPB, and it's like I don't know what you would call it. It's like some kind of solid compound, but it has carbon in it, and when we combust it, it you know, it burns CO2 and also other greenhouse gases. So it's something that we, you know, I think every business on the planet is going to have a strategy to reduce or eliminate its carbon footprint, or at least get to net zero. You know, the most straightforward one for us is, because we don't do that many flights and our total emissions is relatively low, is to start with an offset program. But I think longer term, you know, we'd love to move to engine designs that have even lower carbon emissions. Obviously, like a oxygen hydrogen mix would emit no carbon, which would be terrific. Actually, water, which it would emit, does have greenhouse gas properties high in the atmosphere, but not as much as other greenhouse gases. So anyway, that's the answer to your question.
Yeah, thank you.
And it's I see a question here is yeah, it's a solid, and then we have liquid nitrous oxide as an oxidizer.
Sophia?
Hi, thank you so much for coming and talking with us. It's been really interesting. My question is, how did you originally get involved in Virgin Galactic and all of this space research?
I was originally a customer first, if you can believe it. So I bought a couple of tickets for my wife and I, and then over time they were interested in sort of doing. They needed an executive to help run the business, so they hired me. So that's how I got involved.
That's awesome. Matthew?
Hi, can you hear me?
Yes.
I was wondering, would you mind talking a little bit about what it was like going public?
Yeah, it was sort of exciting. You know, it's a big deal in the American economy, or you know, as is typical for the U.S. And then I went to Princeton for my undergrad, which was also a great place and highly recommended. But there are a lot of great places as well. So somebody said, "What is the grad program called again?" It's called Remote Sensing and GIS, or Geographical Information Systems. Cool. So yeah. Does anybody want to tell me about your program? I'd love to know more about, are you in the same program? Or are you all in different programs? Or how did this group come together? Does somebody want to tell me that?
Yeah, so a lot of us go to Stanford University's online high school, not all of us though. And I have a lot of connections with really cool people like you, and I really wanted to learn more. A lot of my friends and I were like, what do we do with our careers? We didn't know what to do. We're like trying to figure out like what to do with our future like lives. And a lot of times materialism can, you know, sort of drive us and lead us in that way. So I wanted to have mentors who have managed to be super successful while also pursuing service and not only focusing on materialism, give us talks about how they pursue their careers and just, you know, giving us information on their careers and lives and stuff like that. And there was a huge interest of it. So now we sort of have like a community of every week having a new mentor come in different areas. Sometimes we have poets. We're going to have a clothing designer next week. And so that's basically why I wanted to start it.
So COVID really has not been a big change for any of you. It's like, what? Something's happening out. I mean, I'm kidding. It's obviously a big change, but like in the sense that you're used to remote education, and that must be interesting. The rest of the world is getting used to it, but you've been doing it for a while. You probably can give us some tips about how to make it more effective. I have kids who are 8 and 9, and I would say that the remote education that they got was not particularly effective. But maybe that's just an age thing as well. How many people here are interested in science and technology careers versus non-science and technology careers? I'm just sort of curious how it plays out. Okay, so yeah, maybe about a third or something like that. Yeah, cool. Yeah, I mean, both are great. Both are great. And one of the things that we're excited about doing is flying artists into space. I think we're going to fly some musical artists, which should be really cool. And they'll then perform in space, which would be neat. We've never had a professional singer. I think we've had some non-professional singers perform in space, but those have been mostly astronauts. And I think that's going to be really exciting to people to see people who are not professional astronauts do things in space. I think that's going to be a really cool thing. I'm also interested in seeing how like dancers might, you know, what kinds of dance forms they might invent, you know, being in zero gravity. I think that could be really cool. There's a really terrific music video that you should all watch, which is by this band, OK Go. Have you ever heard of OK Go? Probably not. Anyway, look it up. If you just search for OK Go and like zero G or parabolic flight or weightless video or something like that. It's this fantastic video that they filmed on board an airplane doing parabolic maneuvers, which means that they got like 20 seconds of weightlessness at a time. And then they stitched it all together, showing that they sort of had more continuous weightlessness, but it's actually authentic weightlessness. It's just done via a plane. And it's super, super cool. You should definitely check it out. So Supriya, I'm sorry if I'm mispronouncing your name. You always had a dream to do ballet on the ISS. You should totally do ballet on the ISS. That would be amazing. That's what we need. We need more of that. That should be super cool. Yeah, singing in space. Yeah, one of the people who we're hoping to fly would be a very famous singer. I don't think I can say her name, but it's not Beyonce, but Beyonce would be amazing as well. But it's somebody at Beyonce's level. And I think that having somebody like that fly to space it would get the attention of the world, which would be really cool. We got a couple of hands. I don't know, Jada, if you want to call on those people.
Yeah, sure. That'd be so cool. Ben, unless Remy, I don't know if you saw your question.
Okay, first off, I want to thank you for coming and sharing your knowledge and expertise. I am an investor in Virgin Galactic, actually, and I'm excited about the future of commercial space flight. And your company currently has a market cap of around $3 billion, with last year's revenue totaling about $3.78 million. I was wondering what your plan was to grow into this valuation and increase revenue over the next 5 to 10 years.
Yeah, an educated shareholder. Fantastic. Well, it's great to have you be a shareholder. I think the basic idea is just to fly a lot of people to space. That's the idea is to fly a lot of people. And if we fly, I don't know, a few hundred flights a year, then we have this really terrific business. And hopefully we can use that proceeds from that business to do more cool things like, point-to-point travel or maybe orbital stuff, things like that. So, we have, if you're an investor type, there's this amazing website, which I'm sure you've navigated a lot, which is called EDGAR, and it's run by the SEC, Securities Exchange Commission, and all public companies need to file all their documents on that system. And so you can find like a ton of information about any company that's publicly traded on that system. And if you can go to our system, you go to our stock or our company's name, you can look for all these different presentations that we've done for the investment community. If you're interested in more detail, it has a lot of very well thought out, or we hope well thought out presentations on like the plan and the business plan and all that. And so I encourage you to have that. There it is. Man, you guys are fast. Incredible. I agree. No one's at Beyonce's level. Okay, maybe other questions?
Remy?
Yeah, I was wondering about the Starlink system and what you thought about it. Specifically, do you think it will cause any problems with space junk? I know space is such a big place that it probably won't cause any problems with launches, but what do you think about collisions with other satellites and things like that?
I mean, space is big, so like things are collisions are uncommon or improbable. But where they're more common is around the poles, because you often have polar or a lot of satellites cross over the poles, and that's where we've seen at least one collision. The problem is that when you have a collision between two super high moving objects, it's like firing two bullets at one another. It's actually faster than that. You get incredible fragmentation. So, like a single collision can create thousands of pieces of debris. And so it doesn't take too many of those collisions to cause some pretty big issues. I think one of the things that your generation and our generation and other generations will have to be really strict about is trying to prevent these collisions, because right now we're in an early stage and there's no penalty if you cause a collision. But that collision could have an impact for decades, if not hundreds of years. And it's very hard to collect all the pieces. We don't have technology today that could collect all the pieces from a collision in space, because it's creating, like essentially 20,000 bullets spraying out in all different directions. And so I think it's something that we really need to be quite careful about, primarily because it just takes a few events to create a whole lot of debris. So, when a single event can create 10 to the fifth more pieces, and then you don't need too many times for that to happen. And then you get these rings of debris, which will make certain areas of LEO maybe more dangerous to use, which is a big deal. And so, long term will solve the problem, but I think in the meantime, we just have to be really careful about that. And if you have Starlink with, I don't know what, 2,000, 5,000 satellites, and then you have a couple more of these constellations, we're going to be doubling or tripling the number of active satellites in orbit quite quickly. And so I think it's a really big deal, and we really need to be careful about it.
Yeah, I actually have a quick question. How has COVID-19 impacted Virgin Galactic in your guys' work recently?
Well, it's had an impact. We had to shut down our operations in the factory for a few weeks as we thought about how to operate safely. And then we restarted under new protocols. So now everybody wears a mask inside. Everybody gets their temperature checked every morning. We are testing everybody in the company for COVID roughly every month, which most companies I think are not doing yet. And we're being extra careful on cleaning stuff inside and trying to keep people spatially distanced. And the combination of all those things have been pretty successful. We have had very few even possible cases. And we also are lucky enough to live in areas that are relatively unaffected. So while LA is very affected, north of LA in the desert is relatively not affected. Similarly, while northern New Mexico is affected, southern New Mexico is relatively unaffected. So we happen to, and those are our two operational bases. And so we happen to have been, have our facilities in places where there's low incident rates. But I think it's going to be a continued impact until either we have a vaccine or we have super rapid, super cheap testing, which we don't have right now. I mean, right now as we do testing, it costs the company $100 or $200 each. And when you have 1,000 employees, that's starting to be real money. And so, my hope is that we're all going to get like a little toaster and we can, spit on it or something, and it tells us whether we have COVID in 5 minutes. That's what we need, And then if somebody feels ill, then they can just get tested super fast and we can send them home. That'll be really helpful. And I think there's going to be a lot of great diagnostic tools coming out this fall. I also think that there will be some therapies that will be helpful, like that is to say things that make you get better quicker before there's a vaccine. But we've all got our fingers crossed that a vaccine will come relatively soon. I'm not a biologist, so I don't know exactly how real that is, but this is going to be a solvable problem. Hopefully, scientists are relatively hopeful that a vaccine will be possible because the coronavirus is, in a relative sense, simpler than other potential viruses out there. So I'm hopeful, and it's caused us a bit of delay, but so far it hasn't been catastrophic.
Yeah, that'd be really cool to have a toaster. Dylan?
So I remember you mentioning that you use hydroxyl terminated polybutadiene and nitrous oxide as fuels for your hybrid rocket engine for Spaceship One. Is there a reason why you chose those two particular fuels?
Yeah, the main reason was because it was super simple. So HTPB is essentially inert in almost all cases, like at room temperature. It's almost like a rubber. And so you could kick it. You could even take a lighter, a pocket lighter, and light it. It's not very flammable. It's only flammable in the presence of a strong oxidizer. So it means that our fuel is super inert, which is good and safe. We don't have to be worried about, hydrogen is incredibly flammable. It's really hard to manage because it's such a small molecule or atom. And so it's hard to keep it from leaking in your propulsion system. And so we just wanted something that was super robust and inert. So that's the fuel. And then in terms of the oxidizer, the nice thing about nitrous oxide is it's not cryogenic, which means that it's basically we don't have to keep it super cold. Challenge with LOX or other things is that you have to keep it, several hundred degrees cold. And then that has all these challenges for your valves and your lines and everything like that. So we keep our nitrous chilled, but it's just a few tens of degrees below zero. So it's not that chilled. And so that just makes operations much easier. So really what we chose was a system that was simple and robust and safe, or at least safer. The challenge, it's not a very high performance system. So you can get much more higher performing systems, but they're much more complex. It's like a Ferrari engine versus a super simple old Ford engine. The Ford engine is, anybody can fix, and, it's pretty reliable. A Ferrari engine or, a Lamborghini engine creates a ton of power, but it does that through a lot of complexity. And half the time it's in the shop. So that's why we chose that system. How long do the space flights last? They last about 90 minutes from takeoff to landing. You're in space for about less than 5 minutes.
Hi, Lana.
This has been said before, but I just want to say thank you again for your time and sharing your knowledge with us. I really appreciate it. I just wanted to ask like a question. Obviously, we're all still in high school or college, and what kind of advice would you have? As I know you're obviously like super successful, you've done a lot with your life, and it's really inspiring. And I guess what kind of advice would you give your younger self as they were kind of going through it?
Don't stress as much as you probably are about life. That's number one. Number two is just try a bunch of things. Like what I did was I sort of agonized over, well, should I do like this or that or this or that or whatever. It's much easier just to like try one thing, and like quite rapidly you find out whether that thing is for you or not. And then you can move on to something else if it's not. I also think that for anybody thinking about a technical field, it's probably good to do a degree in that. It's easier to start with a technical degree and then go off and do something else later. Technical degrees aren't for everybody, so I'm not saying everybody should do a technical degree, but I am saying like if you're sort of interested in something in that, like it's easier to do a technical degree and then move away from it rather than the opposite. And, you know, I mean, like the key thing that I think high schools, generic American high schools don't do very well is instead of teaching you to sort of try to like hyper excel in like a whole bunch of different things, we don't teach kids as much to learn like to recognize what they like and pursue that. You know, like, I don't know how it is. I went to high school a long time ago, but you know, like we were encouraged to like, oh, you got to do your music and you got to do sports and you got to be great at school and you got to do all these things. And what I think is more interesting, I mean, it's good to do it if you're interested in all those things, do those things, but like, it's more important to like tune up your inner sense of self to understand what do you love doing. My dad became a chemist because he said he liked to wash dishes. And what he meant by that was like, if you're a chemist, you spend a lot of time washing pipettes and stuff like that. Like thinking about like the basic things that you like doing. Like for example, as an executive in a business, from what do I do a lot of? I do a lot of like email and Zoom calls. Like I'm talking to people and then I'm thinking about, you know, whatever, like if that's what you like, then you can do business or something like that. If, you know, if you like making music, you know, anyway, but, you know, being attuned to that is helpful. And I mean, you know, honestly, you guys are going to be able to create your own careers and create your own jobs. And, you know, and that's super exciting if you know, are creative enough and think about it. Like there's going to be all these amazing things that are just, I haven't even thought of. And so I think, you know, if it doesn't exist yet, you can invent it and do it, figure out a business model to like support yourself. Those are a lot of free association things, Alana, but hopefully a little bit of it is helpful.
Yeah, that's really helpful advice, Reed.
Hi, thank you for coming. So I asked the question earlier about, I guess, the price getting lowered, and I was wondering, I guess, what plans you had for how you might actually pull off SUV pricing.
SUV pricing. I mean, basically, with most things in life, if you're producing more of them, they get cheaper usually. Whether it's because you're producing more efficiently or whatever, you can have economies of scale. So, like with this cartridge that we got to replace into the rocket motor every time, you know, that's a thing that we can, you know, get better at building them cheaper, building them better. That's one thing. Also, like it takes a certain amount of people to operate one spaceship, but it doesn't take that many more people to operate a second spaceship at the same place. So we get a little fleet of spaceships, and we're building our next one now. We're actually building our next two now. then we have the opportunity to like save money. Like basically the amount of extra people per vehicle that we're need to hire will be relatively less. So there's a bunch of different things. I think it's entirely possible to get the price under $100,000 at some point. Yeah, so that's the answer to your question.
Okay, and I have a second question, which is, do you guys plan on expanding to any other facets of space? I guess under 5 minutes is not terribly long, and I was wondering if you might slingshot around the moon or something like that. Again, I think
Yeah, all
Sophia
those
might
things
have
would
asked
be.
about the ISS.
Yeah, all those things are super cool. Each of these systems takes about $1 billion to develop, billion or $2 billion to develop. So they're pretty expensive. So you have to do them in order or whatever. And we've decided to take on this one to start. But I think it'd be super cool to attack other types of transportation in space or going to other places. Sometimes you need different vehicle architectures to do that, but it's totally exciting. There's also like all kinds of things going on in potentially space hotels. You could have like a habitat in space that would have these like massive windows. You'll have to avoid your space debris, but like it could be really amazing. So we'll see.
All right, so let's do 2 last questions, and we'll have Matthew and then Annabelle.
Hi, can you hear me?
Yep.
I just want to say thank you again for coming. I know a number of people have said it, but it really means a lot to all of us. You mentioned earlier you were possibly trying to use some of this technology for like point-to-point transport on Earth. I wonder if you wouldn't mind talking a little bit about that, if you have any sort of concrete ideas. And I also wonder, would that maybe compete a little bit with something like a Hyperloop system? Obviously, it would compete with like a traditional aircraft. So how that would work exactly?
Yeah, I mean, I think the primary business case for like a high-speed, high Mach vehicle, by which I mean like over, well, at least supersonic, if not over Mach 2 or Mach 3, is transoceanic. You can sort of go really far. And so, I think Hyperloop will be best suited for sort of short, longer distances, if that makes any sense. Like 1,000 miles or 500 miles. Like Hyperloop is really well suited to that because you just get on it and you go. You'll probably be connected by land to wherever you go, and that'll be great. But for thousands of miles, at least at the start, it'll be harder to do that because the cost of building that infrastructure, and obviously transoceanic will be really hard. But so it'll compete. I mean, with certain things. I think the main thing it'll compete with is long haul air travel. And so, we think today that it's crazy that people took, I don't know, a week to get from Boston to New York. I think your kids will think it's crazy that it took 18 hours to get from LA to Dubai. They'll be like, are you kidding me? That's the nutsiest thing. You go through a sleep cycle and you watch 5 movies and then you get there. That's like so long. We get on this thing and we're there in an hour or whatever. And so there's no reason why we can't do that. It's just we as humans haven't yet actually built that. And so we don't have to build it actually. We have to see if we can build it in a emissions friendly way, I think. And that's the hard part about it. It's hard, but it's not that hard to do it. What's hard about it is to do it in a way that is not throwing out a ton of emissions per person. So that's the hardest part of that mission.
All right, let's have our last question, Annabelle.
Okay, I know everyone's already said this, but thank you so much for coming. It was really great to hear you talk. I have kind of like an unrelated question to the stuff that you've been talking about, but I was just wondering, what do you think the explanation behind the things in space that we don't really understand, such as like black holes and quantum mechanics? If you have like any ideas about that.
Well, I'm not a physicist, so I'm like sort of, an amateur, but I think that the main point I would say is that there's still a lot of great unanswered questions in astrophysics and astronomy. There's the whole like what is dark energy? Is dark energy real? What is dark matter? We have some ideas on that. You know, super fundamental questions about like the majority of the mass in the universe. Those are really huge questions, and so that's exciting. I mean, there's still a lot of science to be done, a lot of things to discover about the universe, and you know, it's like every scientific age feels like, oh, they've answered all the questions, and then they just don't realize that there's like all these huge things behind that thing that they just couldn't even, you know, really gather. And so I think there's just a ton still to learn. You know, like there's this whole question in space, and I'll end on this, is like, there's something called the Fermi Paradox, which you all probably know about, which is the basic question is, okay, well, if in fact there are hundreds of billions of planets or hundreds of trillions of planets in the universe, why aren't we hearing from them? Or where is life? You know, because in theory that would mean that there's like tons of life all over the place, and why aren't they visiting us? And I don't know the answer to that question. There are a lot of really interesting answers to that paradox, which you probably can think about. But my tendency is to say, well, they're not on radio. Like basically the way that we communicate inside our solar system is through radio waves. And they're not on radio because like that's like smoke signals, you know, for them or something, you know, and there's some different way of communicating that is, you know, instantaneous across huge distances or something like that. And we're just not tuned into that yet. And like once we figure that out, we'll be able to, you know, get access to the intergalactic network and, you know, and start communicating or at least hear things. That's my theory. That's my pet theory. It's just like we're really at like a primitive life form compared to the rest of the galaxy, at least intelligent life. But anyway, that's a whole different subject. Maybe we'll talk about at some point in the future.
Thank you.
Let me say, yeah, thanks, Annabelle. No problem.
I know you had one really burning question because he messaged me about it. Would you be willing to answer that one? Sorry.
Sure. Which question is that? What's that? Sorry.
So I had a question about exploring outside of Earth. So I know the Artemis program also looked to explore more parts of the moon, and maybe how could this Virgin Galactic idea that you guys have of having a reusable space shuttle basically help explore other bodies or other planets other than Earth, maybe the moon, Mars, help map those better for future explorations and maybe a moon base?
Yeah, it's a good question. We're thinking about it. I mean, our technology is better suited because it has wings. It's better suited to you know, bodies that have an atmosphere. So not as applicable to the moon probably, but like maybe our propulsion system or some of the structural elements that we use could be potentially applicable to that. So we'll see. But you know, it's definitely there are different ways that we could potentially participate, and it is very exciting. This new exploration or potential exploration of the moon. And so we'll see what happens.
All right, thank you so much for coming. It really does mean a lot to all of us. And we really appreciate it. We'll see you guys all next week for Melody Asani, I think. And yeah, thank you so much.
Okay, take care, everybody. Have a great day. Bye-bye.